All right, let's see if this fixes anything. I'm back. I don't really know how long I've been going on Apex for. Might be running out of steam here. Bit of a scuffed stream too, since I have no idea how long that has been happening. Test one, two. Test 1, 2. All right, it's working on this end. Oh, hot damn. This is my jam. Keep me partying till the AM. Y'all don't understand. Make me throw my hands in the air, air. Shit, didn't mean to open that. You know what I mean?
This is your champion.
I'm the jump master.
Oh, I think we're going hot here.
Trust me, we want to.
I think we're dropping. Stop, drop, and roll. You know what I mean?
Allons-y. That way. Come on.
An enemy land near. Watch yourself.
Weapon enhancement complete. Now for some field tests. Zoot, I think I hear an enemy this way.
Flatline here.
Attention. First blood.
First blood. Good thing it's not us.
Round 1. Beginning ring countdown.
Listen up, I'm getting shot at. Rub the shield now. Stay with me now. And keep the healing coming. Just giving my shields a recharge.
Ring closes in a minute. No time to waste.
Attention. The champion has been eliminated.
I'm spotted. Taking fire. Reloading. Spotted by. Bring it. Recharging my shields.
Attention. Evo harvesters
Can't get up.
are online.
Reloading. The whole squad's been shut down. Good job. Reloading. Planting fences. If the fence gets crossed, we'll know. Planting fences.
Stay with me now. And keep the healing coming.
New kill leader avoided.
There's a new kill leader. The enemy shield is broken.
Bruh.
I believe this is happening.
Alpha squad next.
Adversary ennemi.
There is a new kill leader.
Throwing thermite. There's a new kill leader.
I'm gonna push over there.
We are not alone. Look over here.
Recharging my shields. Fire! Listen up, I'm getting shot at. Reloading.
Negating all incoming artillery.
You're the kill leader. Keep it up now. Hey, Doc. You follow them now, right?
Get a leader.
That fun is so good for me.
I can't hear what you're saying.
Next location is on your map. Have a look, s'il vous plaît.
All right, 2 viewers on Kick. Does my stream look terrible? I changed it from 30 frames to, or from 60 frames to 30 frames. Oh, now it's 1 viewer. It's probably just me. I think, yeah, it does not look great from what I can see right now. People just hit the rift behind us. They're landing on the other side of this mountain.
Attention. There is a new kill leader.
New kill leader. I'll make sure they don't sneak up on us. Weapon enhancement complete. Now for some field tests.
Eliminated.
What? I was the kill leader.
Parfait. I'm at the max level. Excellent. I have an upgrade.
I'm spotted. Taking fire.
That enemy shield is broken. Reloading.
Round 2.
Let's go there.
Keep moving.
Fire. Just give my shields a recharge.
We're in a bad spot.
Just stopping up.
Can you get up here? Come take the zip line.
On its way down.
You're getting pushed, bro. You gotta move.
I'm spotted. Taking fire. Broke the shield now. Reloading. Enemy down.
Bro, let's go.
Say what? Whole squad knocked.
Extended light mag gear. Gold.
Just giving my shields a recharge. Stay with me, Doc.
45 seconds to get to that ring. We need to move.
Hey viewer, how does my
30
stream look?
seconds till
I
ring
think it
closure.
looks really
We're
bad,
so
right?
close.
Is the camera any decent?
My ultimate's ready to go.
Hey, my ult's ready too, you dingus.
10 seconds. The ring is close. Look.
You want to
open
go
door
through there or
over
you want to go around?
Let's go there.
New kill leader appointed. Warning.
There's a new kill leader.
In progress.
Let's go that way.
We need to go.
No, let's
Ring's
not do
moving.
that because that's not in.
The worst that could happen.
You're gonna die in there and be out of circle.
Care package being delivered.
Looks like a care package is
What
coming
dumbass
in.
for me.
Big things in that.
Yeah, I can't hear you.
You know what jump master means?
Yeah, you jump out of the plane.
Weapon enhancements complete. Now for some field tests.
Extra supplies here. Firepower is key.
Team firing. Reloading.
Pushing this hard.
Attention. Blue guns have been restocked.
No more stones.
Gonna replicate this pattern near the sugar.
But you feel like how low I am right now.
Yeah, I can't hear you.
1 minute. Rings close by.
Why is it not on me?
Hey, Doc, come on back. "45 seconds. Rings close."
A few more meters and we'll be inside
Controller!
the ring. 30 seconds to go.
Alright, it looks a lot better. No, it doesn't. It looks fine on my Twitch. Kick looked terrible though.
Backpack here. Gold
I'll
tier.
take that.
We're all inside the
Care
ring.
package being delivered.
Supplies coming in.
Where are you going?
Enemy! Over there! I see somebody!
Heard that.
Taking shots here? They're looking at you
I
maybe?
see an opponent.
Listen up,
Moving
I'm
up,
getting
yeah.
shot at. Got my halo here. I'm healing the shield.
Almost broke.
Inside the ring.
Reloading.
Look out, grenade.
Adversary over there.
I'm spotted. Taking fire.
Throwing an arc star. Look! It's raining. Enemy in sight.
I don't know where the other team is. Staying on high ground over here.
enemy.
They're in this building.
Let's go that way. Laying fences. If the fence gets crossed, we'll know.
Listen up, I'm getting shot at. Just giving my
I
shields a
spotted an enemy.
recharge.
Tossing a grenade.
Oh, that was not even close.
Bang. Reloading. Recharging my shields.
Reloading.
Movement in progress.
We're inside. Recharging my shields. Reloading.
Another squad, I'm up.
You're in a bad spot.
Recharging my shields.
Reloading.
What do you want to do?
I've got people.
Reloading.
Wait for this next circle to move.
Shield is broken. Hold on. Let me help you. Feels like shot in the air.
We're in circle here.
We're safe.
They probably got that res off. Bro, where's your ult?
Reloading.
How do you not have your ult? What the bro? Did you use your ult at one time that game? One more duos and then I'm calling it. At least for Apex. It's already 3? Holy shnikes. I'm 2 hours in essentially with some technical difficulties. Shapoopy. Shapoopy.
Three words: win and win again. Yeah.
Clips are what the civvies use in their hair. This is called a magazine.
This is your champion.
Of course you're gonna die. Civilization's built to make you soft.
Boy, looky here. I've mastered the jump. This might be a good place to land, but what do I know? Follow the leader.
Two teams there? Coming to you.
Yeah, now we're.
Give me a sec. Recharging shield. Enemy spotted.
Faking him out with a decoy.
Can you break that? Where you going, bro?
1 minute until close. Rings nearby. Broken enemy shield. Using the decoy escape.
No harvesters are now available.
Ambush! Ambush! There's another squad!
Gotta patch myself up. Hang on.
My shields are recharged.
Right here, right in front of me.
Reloading.
Wait, hit the right, hit the right. Oh. Alright, time for game dev. Woohoo! Slow day. Really energy is low. Ready to some tech issues. First. Oof. Good news is we're starting game dev, so can do some coding. I need like some caffeine or something. A soda would be really nice. Wow. Let's change up the stream titles. Game development.
The sound design rock.
Sound design. Game development. I've fallen and I can't get up. Just make sure YouTube's working. PewDiePie is done with Google? Whoa. What the heck? Alright, where am I? Looks good on Twitch. It doesn't, it looks fine on Kick, actually. I think it's fine. I think it's fine. Excuse me. Pointer types and get owner. Oh boy.
Hello and welcome. In this lecture, we're going to be learning how we can get a pointer to the owning actor of a component. We're going to find out what a pointer is, what addresses are in memory, and we're going to print them out into our log messages as well.
Lovely.
Let's dive in. So let's take a second to understand a core concept of what's going on in programming in general about variable addresses.
I already
what is an
know
address
this.
of a variable? Well,
I already
we
know
store
this
all of
information.
our variables in memory, in this RAM chips on your computer. And variables require memory to store
Dodge,
their data.
not
So
RAM, RAM,
floating
not
point
Dodge.
number requires either 32 bits of data or 64 if it's a double. An integer requires a certain amount of memory. Also, the bigger the struct you have or the bigger the classes you have, like actors can be very large and encompass a lot of data, might require even a few kilobytes of memory per actor, things like that. Well, that memory has to live somewhere on this large field of empty data that is your memory banks. And that location is known as an address. So how does this work in practice? Well, imagine we have this large field of zeros and ones that is the data on your RAM. Well, then the variable, an A-actor variable called myActor, needs to have a certain location within that memory that is allocated to store the data in the actor. So this red section of memory might be where we're storing the data for this one particular actor, and it has an address, usually denoted in binary or in hexadecimal, that is essentially just the location. If you start counting off all the bytes, all the ones and zeros along here, in fact, we don't actually count the individual ones and zeros, we count in steps of 8, but that's not too important. We count the bytes. That is essentially the address where we start talking about our actor. And then each type has a certain size, so we know that the actor would require so many bytes of data, and so that tells us where to find the data about our particular actor. So why is this important? Well, let's have a look at the situation where we might want to make take two actors. We want to have two variables that reference the same data. Well, in the naive case, we would simply just copy this. So we've got a chunk of memory that is allocated to the myActor variable. We've got another chunk of memory that's allocated to an empty variable called yourActor, which we haven't yet assigned anything to. And then what we want to do, because we want them to contain the same data, is we just assign one to the other. And that essentially results in us just making a copy of all of the bits of data that were in myActor and putting them into all the bits that make up yourActor. So this can be a fairly costly procedure because your CPU has to go through and evaluate each piece of memory in the original and put it into the new location, which takes up time. Now, there's a way around this using something called a pointer. So here, instead of storing the entirety of the myActor, we have a variable called a myActor or an actor, A-actor pointer, that doesn't store the whole actor, it just stores the address where you can find an actor. So you can see it actually uses up a lot less memory to store an address. And then what we do is into yourActor, we store the address of myActor. So it ends up pointing to the original actor rather than copying the data over, hence the name pointer. Now, this isn't the actual syntax in C++. In C++, the syntax is much more condensed. We say that something is a pointer by putting a star after the type. So A-actor star means that this is an A-actor pointer. And to get the address of a variable, we use an ampersand. We won't be making much use of this address of just yet because there's a lot of functions in Unreal that return pointers. So we just need to know how to use those pointers rather than create them for the time being. So one such function that allows us to get access to other objects in our scene is getOwner. So where does this apply? When we've got a component, it is owned by an actor. So if we wanted this component to talk to our actor, to get its location, to set its location, and do things like that.
Where is the mover, please? It was in the door. And there is my mover. Let me just live code this. Static mesh. This ain't what I want. Controller. Movable. Come on, little homie. I added a mover. Did I not? I'm gonna need a backup lecture. I'm at 4 minutes 50. I'm at 5 minutes. Sam
Hello
Patuzzi.
and welcome. In this lecture, we are going to be component, which is a component that. So let's go ahead and hit next. Now we've got to name our component, and we're going to call it simply the mover, and we'll go ahead and hit create class. And instantly it opens up in Visual Studio for me and Visual Studio Code, and I can see that there is a mover.h and a mover CPP, just like previously with the actor, the prefix.
Should be my mover. Found it.
Had been A. And the other thing to note is the name of the function in here. So I'd like to change things like that. Then we need to be able to get a pointer to that actor. We don't want to take a copy of it. In fact, we don't want to take a copy of it because we want to be changing the actor. If we were making a change to a copy, it wouldn't actually show up in the scene. So we need to be able to store a variable that is a pointer to an actor. The way we do this, as we've just seen in the slides, is to have an A actor type, but then we put a star at the end, which tells us this isn't an A actor being stored here. This is just the address of an A actor being stored. So we take the A actor and we're going to call this owner, and then we're going to set that equal to the result of calling get owner. So that get owner is a function of an actor component, which allows you to get an owner pointer, get an actor pointer that points at the owner. Put a semicolon at the end of that line, and what we've got here is a variable that stores the address of an actor that owns this particular component. So I'd like to challenge you to do something by printing the address of this variable. So use the A-actor variable and use the %u format specifier in the logs. So %u essentially means that you're using an unsigned integer. That means an integer that can't be negative, which makes sense because addresses can't be negative when we're talking about where to find memory. And then figure out what does it print. Go and play, see the log message, see what it prints out. Does it change between different plays if you stop playing and start playing again? And what about if the mover is on multiple actors? Is there multiple different addresses printed out in the console? Pause the video and have a little investigation. Okay, welcome back. So we're going to go over to this UE log and we're going to say mover owner address colon %u. So that's where it's going to put the pointer's value. And then we're going to put the actual pointer. So we're going to have the owner in here. So it's going to print out the address of the owner. Let's go over into Unreal, hit Control Alt F11, and when that finishes compiling, let's hit play. And what we're seeing is that the log message mover owner address is coming through, and it's giving us a very large number actually for this address. What if I stop playing and play again? Just for a second, you can see the address of the owner. Let's go over into Unreal, hit Control Alt F11, and when that finishes compiling, let's hit play. And what we're seeing is that the log message mover owner address is coming through, and it's giving us a very large number actually for this address. What if I stop playing and play?
All right, my mover is not in here. I'm looking for a move. Live coding failed. Oh, because it didn't work.
address, colon, %u. So that's where it's going to put the pointer's value. And then we're going to put the actual pointer. So we're going to have the owner in here. So it's going to print out the address.
Can't move.
Of the owner. Let's go over into Unreal, hit Control Alt F11, and when that finishes compiling, let's hit play. And what we're seeing is that the log message mover owner address is.
So it's compiled, but it's clearly not on this. Get the doorway. Was working yesterday. What's the deal here? Let's look at it in C++, shall we? Actor.h. Where's the CPP file? Is there no CPP file? So annoying. Gotta bag it up. Bag it up.
Is to add in some functionality using some. So in the previous sections, we made heavy use of inheritance.
Go, 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 go. Inheritance, we know what it is. We know what it is. Composition. Keep it moving. A platypus is an animal. Yes, yes, yes. Yeah. What? What?
Using some composition, essentially. Let's dive in and see how this is done. So I want to add a section of wall that disappears from view when we place an object on it. So what I'm going to do here is I'm going to go to the content drawer and I'm going to search for the dungeon wall in here. And I think I want this one with a nice cut out section where I can stick a statuette. So I'm going to drag this into the scene and I'm going to rotate it by 180 degrees and try and position it accurately. There we go, brought it down to the floor level and it's looking okay. Now what I want to do with this actor is I want to be able to add a component onto it that gives it the capability of moving itself. Now, we've dealt with components before. We've added ones already created by Unreal, but we've never made our own in C++. So that's what we're going to do in this lecture. So what we're going to do is go to this Add button, and you can see there's an option within here to create a new C++ component. Now, within here, there are a couple of options for different types of components that we can inherit from, so the different types of component we can build. There is an actor component, which is a component that just sits on an actor, any actor. And then there's a scene component, which is an actor component that also adds in a transform and the ability to attach to other scene components. We don't need this functionality, so we're just going to go for the actor component for now. We will be using scene components later on in the section, though. So let's go ahead and hit next. Now we've got to name our component, and we're going to call it simply the mover, and we'll go ahead and hit create class. And instantly it opens up in Visual Studio for me and Visual Studio Code, and I can see that there is a mover.h and a mover CPP, just like we had with our actors. Interesting to note that the prefix to this class is u. Previously with the actor, the prefix had been a. And the other thing to note is the name of the tick function is different. With a component, this function is called tick component instead, but otherwise it is the same. And if we go over to the C++ class, you can see that there is a tick component function in here. So I'd like to challenge you to log a message on tick. So you can add a new log message, add a component to an actor, add your new component to some actor, and see if it prints the message that you have written. Pause the video and have a go. Okay, welcome back. So let's give this a stab. So in the tick component, we're going to type ulog to get the ulog macro to come up. We're leaving it as a display setting, and in here I'm going to type in mover is ticking, exclamation points, of course. Let's go back into Unreal. Actually, what you can do is do a Control-Alt F11 from any place. Actually, you can do it in Visual Studio Code, and it brings up the live coding window automatically. When it's completed, it brings you back over to the editor, just saves you an Alt tab. So what we can do now is you can see this actor does not have our new component on it. So let's go to the Add button, and we're going to search for mover, and then you can see there is a custom component called mover. If I go ahead and add it, you can see it adds it to a separate section to the static mesh components and the other components at the top. That's because these components here, the ones that are attached to each other, are all the scene components, the ones that have transforms that can be attached, whereas the normal actor components, the more simple actor components, go in a separate section down at the bottom.
We're in business, baby. It didn't save.
Is coming through, and it's giving us a very large number, actually, for this address. What if I stop playing and play again? Just for a second, you can see the address is quite substantially different. And that's because every time that we hit play, Unreal is creating a whole new set of actors in the scene, basically ready to play, starting from scratch. So that's why we're seeing new address locations each time we hit play. What happens if I went to this pillar, for example, and added a mover component to the pillar as well, and we hit play and scroll down to the bottom of my logs, you can see that there are each tick 2 different addresses being printed out here because there are 2 different actors which are stored in 2 different locations in memory. So these are the 2 addresses, and you can see there's actually quite a few megabytes of difference between these 2 addresses, which just goes to tell you how much information is being stored in memory by Unreal, and also why it's important to be efficient with not making too many copies. That's it for this lecture. I will see you in the next one where we'll be doing more fun things with pointers. Hello and welcome. In this lecture, we're going to be learning about how we can access what is on the other side of a pointer so that our mover component can get properties from the actor that it lives on, such as getting the name of the actor or getting its location. Let's dive in and see how we can do this. So it's all very well to be able to get a pointer or get an address of an actor, but we do need to be able to actually do stuff with the actor itself. And the process for doing this is a little bit tricky to understand if we're just looking at the actor. So we're going to have a look at doing some pointers to floats just here within tick component. So let's start off by creating a float, which we're going to call my float, and set this to a value of 5. Then we're going to create a float pointer, which I'm going to call your float, and we're going to set that to be the address of the my float. So these are both pointing to the same address in memory. The difference is that your float is an address. So I can't just print out the value. So if I wanted to do a ulog and I wanted to say your float value is equal to %f, then I put in your float. This isn't going to work because your float is a pointer, not an actual float. So what we need to do is essentially get the value at that location. So the way we can do this, if I were to store it in a new float variable called float value, then I use the dereferencing operator, which is actually a star as well, and we put this before the thing that we want to dereference, so we then give it a pointer to dereference, which in this case is your float. Now, it's a little bit strange that we use these stars in 2 different contexts. So one, we are using the star after the type, which tells us that it's a float pointer, and when you're using it with a type, it means that it's a pointer. When you use a star before a pointer expression, what you're doing there is you're saying, get me the value at this location. So then that gets the value and copies it into float value, and now float value we can just print out like so. So with all those contortions, let's go ahead and compile it and see it in action. Let's hit play, and sure enough, it's saying your float value is 5, which is the value we had originally. Now, usually we don't store the intermediate value in a variable because that's wasteful. It's creating a copy that we don't need. So what we can do instead is just use that directly in the expression where we need it. So your float value would be star your float, like so. And that's going to work in exactly the same way, except this time it doesn't make a copy into a needless variable. Now, suppose we wanted to get the name of
That would that would explain it. Succeeded. I can't move.
Of the owner actor here. Well, the way we would do this, let's remove this stuff that we were doing with the floats, is we would dereference that owner pointer. So we do star owner, which actually gets us to the actor itself. Then we can put a pair of brackets around the owner, and then we can do a dot. So we've got the actor out of this expression, and we can use a dot to get something in from inside the actor. So we can do get actor name or label, which is going to return us a f string. So we can do f string name equals to this, and then we can print out mover owner %s, and then instead of using owner here, we're going to do star name, remembering that we need to put the star in front of a name. That's yet another use for that star operator. We've already encountered 3 of them. One is with this string. That's the first time we've seen it. Then it's here with the type, and it's also here for dereferencing. Lots and lots of uses for exactly the same character, but that's how it is with C++. Let's go and try it out and hit play. And now you can see that it's printing out the name of the actors that the mover is attached to. So we've reached through that pointer with the dereferencing operator. It's also here for dereferencing. Lots and lots of uses for exactly the same character, but that's how it is with C++. Let's go and try it out and hit play. And now you can see that it's printing out the name of the actors that the mover is attached to. So we've reached through that pointer with the dereferencing operator and been able to call a function on a different object. Now, there's actually a much more compact syntax for doing this because it's so common for us to want to get a function or property from a pointer object. Instead of having to do this with the parentheses and the dereferencing operator, we can merge this all into one. We can remove all of this, remove the dot, and instead we use this arrow operator. So we do owner, arrow, get actor name or label, and this does exactly the same thing, except it's a lot easier to write. So generally speaking, we'll end up with the rule where if we have got a pointer, we use the arrow operator. If we are using a struct like an f string or an f vector, we use the dot operator.
Blurb.
So I'd like you to print the actor's location using this new knowledge of how we can use pointers. So I'd like you to call get actor location. You're going to be using the arrow operator to look through the pointer and call that function on the object at the other end. You're going to store the f vector that results from that. Then you're going to call toCompactString, store the result in a new f string variable, and print that to the log. Pause the video and have a go. Okay, welcome back. So I'm going to create a new f vector called owner location, and I'm going to do owner arrow get actor location. Then I'm going to convert this to a string, so I'm going to have an f string called owner location string, and that's going to be equal to the owner location dot to compact string, like so. Okie doke. So now we've got our owner location string. We can print that to the log. I'm going to say that the mover owner is this with location %s, and that %s we're going to have another star owner location. String, like so, and then hit Control Alt F11, and we'll go ahead and hit play. And there you go.
This isn't working. Give it up! Give it up! Give it up! Give it up!
We have got both the name of the actor as well as its location printed out as a string. So now we can see the power of having pointers and being able to call functions on pointers. It allows us to communicate between different instances of classes and makes our objects far more useful. I'll see you in the next lecture. Hello and welcome. In this lecture, we're going to be understanding the main steps involved in compiling C++ files in Unreal. Let's dive in and see how they work. So it's soon going to be time for us to start using code from the outside, from other files, and we need to learn how this works in C++. To do that, we need to take a little bit of a detour and understand in more detail what's going on when we compile our C++ code into binary. So here are the compilation steps that are used. We start off with your code, your C++ files, your header files, all in various text files. These get fed into a tool called the Unreal Header tool. Now, this tool is responsible for taking all the Unreal-specific pieces of syntax and using them to generate more C++ code. So let's have a look at some examples of where we've got this Unreal-specific syntax. This U class in capital letters, that is Unreal-specific syntax, and so is the CryptRaider API thing here and the generated body there. And basically what's going on here is the Unreal Header tool will see these different pieces of syntax in your code and go, okay, I need to do my job. I need to go in there. I need to add a bunch of stuff. It's going to replace your generated body with a bunch of code that makes our lives easier when using Unreal. It also does things like the U properties and U functions. It adds all the stuff that it needs so that it can communicate with the Blueprint world. So that is the first step. It converts all of its Unreal-specific stuff into actual C++. Once we've got the actual C++, we can then feed it into a standard C++ compilation process, which takes 3 steps. The first is to deal with the pre-processing step. So this doesn't actually touch any of the C++ syntax, and actually only deals with lines that start with a hash. So we've got a few of these pre-processing directives. These are dealt with by the preprocessor. The next step is what we actually call the compiler. It takes our code and it converts it into executable binary, but it doesn't quite complete the step because it only does it on individual C++, what are known as translation units, basically C++ files. So it takes a C++ file and it translates that into binary individually, each individual C++ file. And then the third step is the linker, which brings all of that together and outputs an executable that we can actually run, a single executable. So let's have a look at these standard compilation steps in a little bit more detail with an example file. So imagine that we had a game.cpp, and it's a very, very simple game because all it does is add 1 and 1 together. But to add 1 and 1 together, it is having to use a function that's declared in a different file, in the math.h. So the math.h declares add, but it doesn't actually define what it does. So that is done over in the math.cpp, and you can see it's a very simple implementation indeed. Now, what happens at the preprocessor step? Well, like I said, it deals with any preprocessor directives, which are things that begin with a hash. So the hash include math.h basically means just copy everything in math.h into here. So what it does is it takes these 2 files and it combines them together to create a new output file called game.i, basically game.include, and you can see that it has included the definition from math.h and it's replaced the hash preprocessor directive. So now game.i has got a definition for the add operation. And then we run the preprocessor on math.cpp, but because it doesn't have any preprocessor directives, basically nothing has changed there. The next step is the compilation. This is probably the most important and complicated step because what it does is it takes that C++ in each individual .i file and converts it into binary. But it's not complete binary because, for example, my game doesn't actually know how to implement add. It just knows the shape of that add function. So that needs to be filled in later, and that's filled in by the linker. So the linker is going to take the binary created for the game.obj file and the binary created for the math.obj file and bring them together to make a game.exe, which combines the binary for both, and finally is a complete executable that we can actually run because it's got the definition for everything it needs. Now, why do we have such a complicated process? The idea here is that it speeds up our compilation time, because if I only made a change to game.cpp, I don't actually need to run the entire compilation process. All I have to do is run the bits involving game.cpp. So I'd run the preprocessor only on the CPP, then I'd run the compiler only on the game.i, and then I can reuse the math.obj file from before. I don't need to recompile it because nothing has changed in that. Similarly, if I only change math.cpp, I wouldn't have to recompile the game.obj file, which is why this is a more efficient process and why we're doing it in the first place. So I'd like us to do a little experiment and try and figure out why do we include mover.h in our mover.cpp file? What's the reason for it? Why can't we just compile the C++ file without including mover.h? So the experiment we're going to do is we're going to comment out the hash include line, so using a double forward slash to make a comment in front of that line, which will basically make it get stripped out by the preprocessor instead of the preprocessor replacing it with the contents of the file. We're then going to recompile, and I'd like you to have a look at the error messages that come out and see what it says to see if you can try and understand what it is that we're including this mover.h.
Wait.
Why do we include mover.h in our mover.cpp file? What's the reason for it? Why can't we just compile the C++ file without including mover.h? So the experiment we're going to do is we're going to comment out the hash include line, so using a double forward slash to make a comment in front of that line, which will basically make it get stripped out by the preprocessor instead of the preprocessor replacing it with the contents of the file. We're then going to recompile, and I'd like you to have a look at the error messages that come out and see what it says to see if you can try and understand what it is that we're including this mover.h for. Pause the video and have a go. Okay, welcome back. So let's put a double forward slash at the beginning of this line, which basically makes it null and void. And then we're going to do a Control-Alt-F11, and we're going to have a look at the output of live coding. So look, we've got some errors straight away, very, very early on. And what it's saying is that uMover is not a class or namespace. And there's some other stuff down here. It's saying that primary tick component hasn't been declared, that super isn't a class or namespace, getOwner is an unknown identifier. And basically what this is saying is you've talked about uMover here, but you've not defined it anywhere. You've not declared it anywhere. So I don't know, the C++ compiler says, I don't know what this is. So that's why we are hash including the mover.h, because mover.h declares the class. It says a uMover is a class, and it derives from uActor component, and it's got these methods, etc. It's declaring what it means to be that class. So without that declaration, the C++ compiler can't continue, and that's why we need to include that header file. Great stuff. So hopefully you now understand a little bit better the process involved in compilation of C++, and particularly compilation of C++ in Unreal. I will see you in the next lecture.
I'll see you in the next lecture.
Hello and welcome. In this lecture, we're going to make our mover do some moving by checking a checkbox. We will enable it to move and move at a constant speed. And we're going to be doing this using some library functions this time from within Unreal. So it'll put all of our knowledge of header files and includes to the test. Let's dive in and see how it works. So the way I want this mover to work is that I want it to move smoothly from where it started to a target offset over a period of a certain number of seconds. So the way we're going to need to configure this is to add in some U properties into the header file. So let's start off by adding a private section to the header file. And then we're going to add a U property that's going to be edit anywhere, which is going to define the offset, the move offset. So how far this mover should move when activated. So the way we're going to do that is we're going to use an F vector, and we're going to call it the move offset, like so. I won't give it a default value. We'll do that in the editor. Then I'm going to create another U property, which is again going to be edit anywhere, which is going to be the amount of time it takes to move to the target. So we're going to have that be a float, which is move time. I'm going to set that at a default value of, say, 4 seconds. Now, there's one more thing that I want to put in here, which is a Boolean, just for now, which is going to allow us to activate the mover so that it's going to move down when we activate this Boolean. So let's create another U property, again, edit anywhere, so that we can edit it even while we're playing. And this is going to be a Boolean saying should move, and by default, it's going to be set to false. So when we check this off in the editor when we're playing, it's going to go and move to its target move offset. Now, previously, when we had a moving component, we did all the steps manually, but I want to show you that there's actually some functionality built in to do a lot of the calculations we need. It's built right into Unreal, and there's a function called vinterpConstant2. And what's interesting about it, let's have a look at the remarks. So it interpolates actually some functionality built in to do a lot of the calculations we need. It's built right into Unreal, and there's a function called vinterpConstant2. And what's interesting about it, let's have a look at the remarks. So it interpolates a vector from a current vector to a target vector using a constant step. So that means that over time, we're going to move from current to target at a certain speed, and it's going to do that constantly, which sounds like exactly what we want. We want to move from our current location to a target offset location at a constant speed. Now, you can see, if you have a look at the syntax for this function, you can see that it has a return type of f vector. So that's the new location that it's interpolating. Then it has 2 inputs. We've got a current f vector, and don't worry about the other symbols around this f vector for now. The important thing is that it is a current f vector, and then the target that we want it to eventually reach. Then it has the delta time, so it uses this to make the movement frame rate independent, and the interpolation speed, so how fast should we be moving from our current location to the target. Now, you will notice that up here in the documentation, it actually has a section that says include. And this tells you the include line you're going to need in your C++ file in order to be able to use this function. And as we've seen in the previous video, the include line allows us to copy in the definitions from this particular file. And one of the definitions is the definition for this function. So it allows us to use this vinterp constant2. Now, the v in front of this function basically means that it does interpolation on vectors. That's why it's called vinterp2 as opposed to other interpolation functions that are also available in this library file. So let's have a look at how we would use it. First of all, we're going to copy the include line from the documentation, and we're going to go over into our mover CPP where we want to implement this in the body of the tick component. But the include, we do not include within the body of the tick component. We have to do the includes all at the top of the file. So that's where I'm going to put mine. I'm going to put mine after the include of mover.h. So we're going to put in an include for math/Unreal Math Utility.h. Now, what we can do is we can actually use the function include for math/Unreal Math Utility.h. Now, what we can do is we can actually use the function within our tick component. Let's just get rid of the code that we've already got in tick component because we were using that to understand how to call functions on other actors. And what we need to do is if you scroll up, you can see the way to call this is fmath:; vinterp constant2. So we're kind of doing this : operator that looks inside the fmath class, which organizes together all these math utilities. So we're going to do fmath:; and here you can see a bunch of autocomplete coming up for different maths functions included in that header file that we've just included into this file. So you can have a look through, see any of the interesting stuff is in here. I can see a bunch of interpolations, circular interpolations, etc. But we wanted the vinterp constant2, and we can hit tab to complete that, and then open some parentheses, and we can see the arguments that we need to be passing in: the current, the target, delta time, and the interp speed. So let's start creating some variables to hold some of these. So first of all, we need an f vector, which is going to be our current location, and we're not going to set that for just yet. Then we're going to have an f vector for the target location, and then we're going to get a float for the speed. And we're going to have to calculate each of these individually to figure out how we can make this movement happen. So the current location is going to be relatively straightforward. We need to get the current location of the owning actor. So how do we do that? Let's replace this semicolon with an equal sign. Then we're going to do a get owner, pair of parentheses. Then we're going to do arrow. So we're going to be calling a function on the owning actor. And we're going to do get actor location, and then a pair of parentheses and a semicolon to end it. So that gets us the current location of the owning actor. Now, what about our target location? Well, we know that we've got a property called the move offset, so that's going to be involved here, but we do need to add the original location to this move offset. So for that, we need to capture the original location in begin.
Where did I make move offset? It's supposed to be in mover.h. No, it's here.
Play. So we need a variable to store it in, so let's go over to our mover.h, and it's not going to be an edit anywhere one, so I'm going to put it under our uproperties. It's going to be an f vector called original location. We're not going to set it to anything here. Then we're going to go over into our mover CPP, into begin play, remove this comment line, and put our own code, which is going to be that the original location is equal to get owner parentheses arrow get actor location, like so. So now that we've got our original location captured in begin play, we can use it in tick. So we go over into tick and we set our target location equal to the original location plus the move offset. So that's our target location. And finally, our speed. Well, this is essentially the distance that we need to move divided by the time at which we need to move over. So if we've got a target location and we've got an original location, we need to find the distance between these two, which we can do with an f vector : distance. Then we pass in to the parentheses the original location and the target location. So that gives us the distance between these two vectors, and then we are going to divide that through by what did we have over in mover called the move time. So that gives us the speed at which we should be moving. And now we can use these as arguments to our vinterp constant2. So we've got, first of all, we need to give it the current location and then the target location. Then we're going to tell it the delta time, which is just already a parameter in tick component, so we just need to pass that through. And then we've got the interp speed. So we're just going to pass in the speed, like so. We'll put a semicolon on the end of that line. And this is essentially the new location. So let's store that into a new variable, f vector, called new location, equal to this. Cool. Now we need to do something with that new location because it's no good just having calculated it. We do actually need to move the actor to the new location. So that's what we're going to do. We're going to call it on get owner. So we do a get owner parentheses, arrow, and then we're going to do a set actor location, and we're going to pass in the new location like so, and have a semicolon at the end of the line. So let's go ahead and compile this and see if it works. So if we go over into the dungeon and select the wall that we want to move, you can now see that the mover component has got a move offset, which I'm going to want to do in the...
Be surprised if this compiles. I would be surprised. We're getting hung on something. Oh, there we go. Get owner. Seriously? Where is this one? That wasn't as bad as I thought it could be. Controller. Failed. Oh. How did I not fix this? 41.2. I thought I did. Control Alt F11. Oh, I don't know what happened. On the fly. Yeah, buddy.
The Z direction, and I think I'm going to do minus 600. And then the move time 4 seconds should be just fine. So let's save that and then hit play and see if it moves. So it's not moving, and there's an error in the output log saying that the mobility of the actor has been set to static, which is why it can't move. So if we select seconds should be just fine. So let's save that and then hit play and see if it moves. So it's not moving, and there's an error in the output log saying that the mobility of the actor has been set to static, which is why it can't move. So if we select the actor again, you can now see that the mover component at the end of the line. So let's go ahead and compile this and see if it works. So if we go over into the dungeon and select the wall that we want to move, you can now see that the mover component has got a move.
So the mover component is in here, which is fantastic. Don't need to re-address, save.
Move offset, which I'm going to want to do in the Z direction, and I think I'm going to do minus 600. And then the move time 4 seconds should be just fine. So let's save that and then hit play and see if it moves. So it's not moving, and there's an error in the output log saying that the mobility of the actor has been set to static, which is why it can't move. So if we select the actor again, and we look at its mobility settings, you can see, in fact, the mobility settings of the static mesh component. So select the static mesh component, then look at the mobility, you can see it's set to static, which basically means it's not allowed to move. Let's switch that over to movable, because we do want it to move.
Okay, I don't know. Did I? Ah. Cool.
And then let's go ahead and hit play. Now you can see in the darkness that the wall was going down, which is perfect. I do think we've got a mover somewhere else in our scene, up on this pillar here that it's also trying to move, so let's not do that. Let's delete the mover component that we added in there just for testing, and it should give us no errors in the output log. If we go ahead and hit play now, we should just have that wall going down to its target location. So let's challenge you to make it move with the Boolean that we created, that U property. So you're going to wrap the code in an appropriate if statement and the appropriate code so that it only moves the platform when that Boolean is true. And then you're going to recompile the code and play and eject using F8, and then change the Boolean and observe.
What the is going on?
See whether it moves when you check that Boolean. So pause the video and have a go.
Where's my bool? We boolin'. We boolin'. Yeah, buddy.
Okay, welcome back. So let's go and wrap this tick component stuff in an if statement, not super, but everything else we're going to do if should move, then open some parentheses and move all this code in, remembering to indent it one level because we're inside parentheses and we want to show that this would only be executed within the if statement, make it easy for us to read. Control-Alt-F11 to compile, and then we should be able to go and hit play and hit F8 to eject if we have got our mouse captured. And then we're going to go in to have a look at our outliner. We're going to try and find the wall, or we can just click in the scene, and then we're going to select our mover component and check should move. And there you go, the wall starts to move when that happens. Great stuff. I will see you in the next lecture. Hello and welcome. In this lecture, we're going to be making our very own scene component for the grabber, and we're going to print out its rotation so that we can see that it is indeed attached to the camera and the camera's rotation is affecting its rotation. Let's dive in and see.
I feel like this is important. I'm like really tired right now, and I don't think I want to do it. I think I hit an hour, so I might just stop here. Low energy. I'm sorry. Oh, save selected. There's a good chance I do some more development just like on my own because it's moving pretty slow, just doing an hour at a time, and I feel like I want to get through this tutorial and start building my own thing. Not that like I think this is still really good, it's just I do have an idea and it's like I would like to start progressing towards that idea, but I mean I could just do it. But I feel like if I do this tutorial first, I'll have a better Alright. I'm really gonna try to stick to an hour here too, just because of how tired I am. Let's go get my elytra. Got a lot of shit in here. Yo, these Endermen are getting cocky. I probably was so close to wherever it was yesterday and just like turned around. Do a little dance. Make a little love. Get down tonight. Why is there a zombie making noise? Get down tonight. You know what would be spectacular? Fuck you. Did I just lose that shit? brother. I'm going to lose my mind. Fuck you, I suck. Oh my god, I probably should have gotten... Alright, it's got to be around here. I don't necessarily need it. I just want it. Is it like right here? It was a lot closer than I thought it was. It's gonna be over there. Oh, shit. Right? Yeah. Don't break, don't break, don't break. Ow! Ow! What the? Ouch, Charlie! Is this it? No. Fuck, do I have a water bucket? I do. Is this it? I might be close. Alright, I'm gonna back up a little bit and do it. Don't break, don't break, don't break. Yes. Oh, here we go. Is this it? No, that's... I could have swore it was up there. I knew it. Oh, it's this. Here we go. All right. Where's my notes? My notepad. Minus 1691, minus 1327. Shamalama ding dong. minus 16, 91, 1327. Lovely! Now let's do this. No, that. Why is that happening? You better chill, dog. Oh, homie. Oh, shit. Am I gonna die here? Keep going, little bitch. Holy fuck. No, I'm chilling. I don't think I can use water for anything in the end, but I would just like to have a water bucket. Generally. What's the deal here? Yeah, okay. I don't know why Minecraft is doing that. Fire aspect and loyalty, sharpness 3, piercing 3. Oh, I know. Can this go in there? Can this go in there? No. Where's the ladder? Did I already take the... What can go in this bundle? Books? Can we put more books in there? Yeah, we can, but whatever. I'll just carry some books. There's emeralds. Fucking should just throw that out. Whatever, it's fine. Isn't like density sometimes in here? I just picked up. Oh, just some blocks. Oh. I mean, yeah, do I want to explore this a little bit? No, let's just go get the freaking elytra. Where is it again? No, it's just this way. not this way. Or is it? Enderman. Hey. All right, I gotta go back. Jesse, we have to cook. Oh, please, just tell me where the portal is. I'm going the wrong way. Brother. Which way, brother? Books. Okay. This is the same room that I was in before. Yes, it is. Okay, I'm back here. How did I find it so easily last? Up here we go. Oh, fuck! I didn't mean to reset put my respawn point there. But sure, we can dump a lot of stuff here because I'm gonna need the space. Alright, let's do it. Ain't nothing to it but to do it. Don't quite know what I'll do with that, but slurp. I'm gonna need to get some ender pearls. I really wish I had a better sword. Maybe I can find one. Well, at least I have a sword. Holy hell, how are you fucking hitting me? This is so scary. Probably not gonna use a shovel. Probably will keep the axe out. Definitely want some. Probably not gonna use those. Probably not gonna use the lava bucket. Plenty of time to get some more, but might as well get like some stack doodles. Oh, you know what I'm gonna use? This. let's just get in there, see what we're up with. Mama. Alright, gonna need to turn my render distance all the way up. Do I want to just like look on chunk base? I think maybe. Already 20 minutes in. I think I am going to do it. I think I'm going to chunk base it. Just to save time. Chunk base. Is it Ender Cities? One more, right? Shoot. What is my... I'm at 59,348. No, that's the chunk. I'm at 958,6772. 958,6772. All right, there's one at... $13.60 $400. So it's that way? No, wait. We go negative X, positive Z. Oh my gosh. Freaking out, man. I'm freaking out. I mean, in theory, I can just jump across. Hoo-yah! More negative y, I think. Negative x. I gotta go 400 in that direction. I gotta go 400 in both directions. So this is a big one. God damn it. You know what would suck? For some reason, like, my shift stopped working. I was so scared. Mommy. I might not have enough blocks here. I'm so tense, I'm afraid to lift up. Oh. 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 Alright. E now. Do this. Oh, I'll make it. Please. Yes. Ho ho ho. Let's do this. Oh, there's the city. Yes, does it have a... It looks like it might have a boat. Yep, that's a boat. Big time. Just gotta get over there. What's the best route? Probably here. Or do I go diag? Diagon alley. I think I'm gonna go for it. Okay. God, don't look at me. Diagonally. Alright, we're gonna work out these pinkies. Pinky strength. Just relax. We're just going for a stroll. Absolute emptiness behind me. Fuck, I'm already regretting this. Music isn't helping, oh my god. This is like torture. The release. I throw a pearl and it goes into the void, will I like, doesn't hit anything. Will it still teleport me to the bottom of the void? Like, if I did go for a pearl throw, because I thought I was close enough, but I short it, is there like a negative? Let's not think about it. We're just building, we're just blocking. Alright, after this stack, I'm gonna see where I'm at. My arm is getting tired. My forearm, because my pinky is just flexed. Oh, we are close. Eerie noise. Don't you be eerie noising me. Hey. None of that. None of that, please. Well, I'm certainly not tired anymore. This has woken me up. Oh my gosh. Just go. Just go. Enderman, whoops, I'm close. Probably not gonna make it there. Chloe! Scammer! Who's the scammer? Appreciate the follow though, Chloe. You real one. You real for that. Oh my gosh, I'm so freaking. How far is this fucking... I might be kind of... No, I got other blocks. I'm also a graphic designer. I'm from the US. Cool, man. Very cool. Hot opener, by the way. Coming out with Scammer. Is that your pitch? Like you are a scammer, or you're looking for scammers? It's going alright. Kind of tired, although I'm just freaking stressing right now because of this fucking void shit going on. How are you doing? How's your day? Tell me about it. What'd you have for breakfast? Oh, I don't think I'm close enough yet. I got cobble, baby. Let's cobble it up. Oh yeah, we're good. Cobbly cobble. Oh, okay. Just relax. Just relax. We're cooling. We're cooling. Give me the freaking elytra. Why did that happen? Scary! Scary noises! I'm not a scammer. Okay. Good to know. I'm not really interested in anything right now, Chloe, but appreciate you reaching out. What did you have for breakfast today, Chloe? God. Make sure that pinky's pressed. Oh, all right. This is hearing the sound of an Enderman is comforting in this moment. Yeah, I can totally pearl there. I can totally pearl there. Am I gonna do it? I think I am gonna do it. Yeah! Don't know I want to improve my ID? Yeah, of course I do, but I'm not gonna pay for anything. I don't even know what ID is. What is that? Internet? Domain? You still haven't told me what you had for breakfast. Which leads me to believe you are a bot. A very sophisticated bot. Wait, where's my bow? I don't have a bow? Chorus flower, that's new. Am I blind? Yeah, I would mind because you haven't answered my breakfast question. In my mind, you are a bot. Bot, 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 bot. What the fuck? No, I'm not interested. Blah, blah. Yes. I'll take them. Yeah! What can I put in here? How about this? How about this? How about this? No. Those can't stack? How about blah, blah. Blah, blah. Do I want the dragon head? Kinda do. Um, Hey! Be nice to me! Oh my gosh. Grab onto that. Grab onto it. Levitate, levitate, levitate. Oh, come on. No, 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 no. Yes. No, 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 no. I would like a shulker box. No, you bitch. Why am I not just... Oh my gosh. No! What the... Did you give me a shulker? Yes. Blah. Owie. Oh, here we are. Blah. Who's all here? Where are the shulkers? Where are the shulky babies? What the fuck? From deep, bro. Oh. Shulker box, please. Owie, where? Bro, what the? Branch is a VTuber. He's a big scammer. Please don't trust him. I always see him scam other people. I don't know who you're talking about. You talking about Chloe? What are you talking about? Wait, how do I get... Isn't there a way to... I got the egg. Sloop. Oh wait, how do I make an ender chest? Am I missing something? Is something else going on in this kick chat that like I'm just... There's my bow. Oh, shoot. Nuggets. What is that? Starfish. Silverfish. Wait. How? Alright, whatever. It like doesn't matter. I'ma tell you to run. Say, buddy, you pick me up where? What? All right. Big day. Tomorrow's gonna be even bigger. Oh, what are you giving me? Bane of Anthropods. Okay, that's it.